I'm Gurjeet Gill from University of Adelaide and speaking at the GRDC update in Adelaide about our latest weed research. With brome grass we've been looking at why this weed has continued to increase in dominance across the state and southern region. And one of the issues that's come up through our research is that brome grass has developed mechanisms to escape early season weed control. So what we've been finding is that populations from the farms in the southern region, they have evolved mechanisms that delay their establishment to much later after the crops have been planted. And that's fascinating because when the farmer then goes in with the knockdown treatments, they're only killing maybe 10-20% of the population, and the rest of it's coming up later in the season, which means there is greater pressure on in-season control tactics. And because brome is so competitive, it then means the yield losses can be quite severe. It's got multiple mechanisms. One is that it requires dark for germination. And in no-till systems, which is where most of our growers are, that darkness only comes after the seeding operation when the soil has been thrown over the top of the seed bank. But interestingly, the change has been in the requirement of seeds for cold exposure before they'll germinate, which means that cold, we were looking at 4-degree type temperatures at night, they only start to come when we are right into winter. And as a result, what we're seeing is our populations are coming up in June, July, rather than where a farmer would be wanting them to come up in April, May. So as a result, our control performance has been going down. And so we've been investigating populations in our new GRDC project, which were collected from many farms across the southern region. And that difference between cropping populations late emergence versus fence line or non-crop populations coming up early was very consistent across the region.
Right, yep.
So we have in an associated project, we've been looking at a range of species with treatments in kiln to expose them to very high temperatures, similar to a burn in the paddock. And we've been finding that you need temperatures of the order of 400 degrees plus for up to 40 seconds to get effective kill of grasses. And those sort of temperatures are easier to achieve, and durations are easy to achieve in narrow windrow burning, but not in your burn across the paddock or in seasons with dry finishes where the biomass present might be low. So we were surprised that some of the species were quite tolerant to those high temperatures. So you're looking at 400, 450 degrees for 40 seconds to kill most of the seed bank. Because this area has been receiving a lot of attention, rightly so. Because it offers us non-chemical tactics for controlling weeds and integrate them with herbicides. So one of the basic requirements for harvest seed capture to work is the seeds have to be on the plant. If they've already been shed before harvest, these systems aren't going to work. So we were interested in looking at a range of species within this new within GRDC project to see how much seed was retained. And what we found was that barley grass, by the time you could harvest your wheat crop, earliest opportunity for harvest of wheat crop, only about 5% of the seed was left on the plant. And the shedding of the seed started about a month before crop harvest could have been done. So barley grass is not a candidate which suits this harvest weed seed capture. But other species such as brome, for example, they're easier to capture, especially in wetter springs. We found in 2016, where we had really soft finish, about 75% of brome seed was still on the panicle, so you could have captured it and destroyed it. But in 2017, when we had very dry spring, the seeds became much easier prone to shedding, and only 25% of the seeds were on the plant. So what it's shown is that there is quite a strong seasonal interaction with the effectiveness of harvest weed seed capture with some of these species. So that's quite an interesting but important development. We are looking at obviously several other species. So there are 11 species being investigated. So we will be able to get quite a strong rating of species which are most prone to this tactic, so harvest weed seed capture. So we'll be able to rank them, but we will also appreciate by the end of the project, how the shedding behavior changes between seasons, but also between crop types. So we're doing assessments in wheat, but also in lentils. So one a more competitive crop and one which is quite a weak competitor. So this will give us really strong understanding of the likelihood of success in terms of capturing these seeds and managing them at harvest time.